So in the mixing guide, I talk about hue, value, and chroma as three components of color that we consider when we're trying to match a specific color. And I had a few questions about that terminology, about that way of thinking about color. So this is a page from the Munsell student set. So Munsell was working in the early 20th century, and he developed a system of describing color, kind of coding color, on the basis of those three components: the hue, the value, and the chroma. So the hue is what we think of generally when we think about color. So the hue is basically the color of the rainbow or of the spectrum that whatever color we're looking at fits into. So for instance, in this case, all of these colors here are red hue. They're red and hue. So they fit kind of in this range in the color wheel. The next component would be value. So this is the value scale. Munsell uses a scale that goes from 0 to 10. But 0 and 10 are kind of limits, absolute black and absolute white. So this scale actually has 9 values. So this particular color of red that we're looking at here, these are all value 4. So I had a question about value in relationship to the warm cool palette guide, mixing guide. And so yes, every number value 3 for each of the columns, it should be the same level of lightness or darkness. Now I will say that when you have a more saturated chromatic color, so we'll talk about chroma in a minute. So chroma is where the color is, whether it's more colorful or whether it's more gray. So this little row here of the gray towards the red, this is all the same hue, all the same value, so it's all the same red, it's all the same lightness or darkness level, but it varies in chroma, so it's getting more chromatic as it goes towards the right. It's how colorful it is versus how gray it is, okay? And then you reach neutral, which doesn't have any hue, so it's just neutral. So the problem with, especially, I've sent you the mixing guide, but it has photographs in it. So when you're looking at the photographs, it can be difficult for both our eyes and the camera to determine the value, the tonal value of a high chroma color. So when I look at some of the photographs of the mixtures, especially when they then print them out and look at them, some of the higher chroma colors look a little bit lighter because sometimes we interpret that high chroma as brightness, but it's actually not lighter in value, it's just brighter. But sometimes the camera will make the same kind of error. So that can be a little difficult to determine. But you just do, you kind of do your best. And the lower chroma colors are a little bit easier to judge the value compared to gray. So yes, the value is kind of a universal, the numbers should be universal level of lightness or darkness, no matter what the level of chroma is. And here's an example of that. So this is a page from the Munsell student set. Now I will just mention these, you can usually get these books for under $100. And they don't come assembled like this though. There's some text and exercises. There's like a section of just like text and exercises. This is a 3-ring binder. And they have some writing and explaining things in here. And then in the back there are these charts, but they're not assembled. They come with these little chips in these little plastic bags, and it might depend on what edition you get, how it looks. And sometimes if you get it used, they're already assembled and may or may not get all the chips. So, but the chips come in these little, again, depending on the edition that you have, this is what the chips look like. You have to kind of take them apart and then put them on the page. So sometimes it can be a little tricky, you know, if you're not used to this yet, to figure out where everything goes, but you just kind of keep moving them around until it looks similar. And there's lots of examples of assembled charts and digital charts that you can look at to help you. So this is a page of 5YR. So he had a very funny way of naming the hues. So the numbering system can be a little bit confusing. So that's, you know, I didn't get into it too much in the mixing guide except to number the values, but he also numbers the hues and the chromas. So the values are, you know, you may be used to a value scale that is in the reverse. So some people use value scales where the higher numbers are lighter. Some people use value scales where the higher numbers are darker. So in this case, the higher numbers are lighter. So it goes from 0 is black and 10 is white. And then the chromas go from 0 is neutral, and then as you go up in number, they get higher in chroma and more colorful. So that kind of makes sense. The order, so if you're looking at the code of any particular number, the hue comes first, then the value, and then there's like a slash and the chroma. So that can be a little bit confusing to kind of get used to. But now the hues are a little more complicated though, because for one thing, the numbering system is just kind of arbitrary. They're basically arranged in a color wheel, but then the names are a little funny, for especially the YR, which happens to be the color that's basically our warm cool palette. So YR stands for yellow red, which is orange. So why he decided to call it yellow red is, you know, maybe questionable, but YR is basically orange. So the number 5 just indicates that it's kind of a middle orange. So if you go in like 2.5 YR, for instance, would be closer to red, and 7.5 YR would be closer to yellow. So that takes a lot of getting used to. I still get confused about those numbers. But basically YR is orange. So let's see, so the chroma, again, this is kind of the most difficult concept for artists to wrap their heads around. You know, a lot of us are familiar with value, we're familiar with hue. Chroma is a little bit confusing, and a lot of people understand it in terms of temperature, which is one reason why I used the term warm-cool to describe this palette. Even though warm and cool are relative terms, they're less specific. They can confuse the issue a little bit, but I think that for this particular set of colors, it does make sense, and so I think it's a useful term, although it can be a little confusing if we don't completely understand what's happening. So if we think of warm as being orange and cool as being blue, so the colors that are warm are kind of around orange, the colors that are cool kind of around blue. And in this particular case, they're also mostly complementary. So we can actually mix the oranges towards neutral, and they'll also be moving towards their complement, which is blue. So, so that kind of works for this particular complementary pair of a kind of medium-high chroma orange, which is the transparent red oxide. Transparent red oxide won't get you like these colors, okay? You're gonna need to get like cadmium orange or something for this, but it'll get you maybe in this range mixed with white, okay? And then mixed with the black and white, mixed with the gray, it'll start to move towards neutral. And then the black and white move just very slightly into the blue range. So, so that's kind of how I determined to call it warm and cool. Also, I mean, I didn't actually name the palette with those particular pigments. That's a palette that I learned, but we didn't mix it out like this. It wasn't a, you know, segmented out into these numbered charts quite as thoroughly. So let's see. So if we look at this page of the mixing guide, you can kind of see that these palettes are set up. If we imagine that there's a neutral over here as well, and then the slightly cool gray, they're kind of set up like this chart, right? Especially this one. This one's kind of in reverse, but this one is set up where the neutral, slightly cool gray is over to the left, and then moving towards the right, we get more chromatic. So each column is all the same chroma. Each column is all the same number of chroma, level of chroma, amount of colorfulness. Each row is all the same value. So all the same level of lightness or darkness. Okay, so this is one that I mixed more steps of both chroma and value than the recipes that I gave you, but kind of the same idea just for our simplified palette. So if we look at this chart here, and I have this one reversed as well so that the gray is over here, but all of these columns should be the same. Well, each column, all of the swatches in each column should be approximately the same level of chroma, amount of colorfulness. And then each row should be about the same value. Now again, like for instance, this one, you know, this might appear a little bit lighter to you than this gray, just because of the way that we perceive chroma and the way that maybe the camera captured it. It also could be my own mixing inaccuracy, but so yeah, basically each value number should be about the same level of lightness. It's universal. It's not just specific to each of the colors. And these are both the same approximate hue. They shift a little bit, does shift a little bit in hue, but they're both basically orange. Just higher in chroma, lower in chroma. I should also say this column, the lighter colors are going to be lower in chroma just because, like if we look at this chart, for instance, it doesn't actually go up to value 9. And as we look at the number of chips, these are called chips, color chips, little rectangles, number of chips in each row, we can see that value 7, you can get more chromatic than you can at value 8, because to get to value 8, we have to take our, let's say this is cadmium orange if we wanted to get that chromatic, and add white to it. When we add white, we're desaturating the color and lowering the chroma. It's not quite as colorful. It doesn't have quite as much orange in the mixture, okay? The same thing happens with the darks. So in this case, the transparency of the color kind of complicates things a little bit, but when we see the body color of transparent red oxide all piled up together, it's not quite as chromatic as when we add a little bit of white to it. So in this case, you can see that as you lower the value, you're not able to get quite as chromatic either. So there's a certain value range, and it's different for every hue. So yellow, for instance, is most chromatic at the lighter values. Blue is more chromatic at lower values. Or is able to get more chromatic at lower values. Yellow is able to get more chromatic at lighter values. You can always lower the chroma. You can't always make it more chromatic. It depends on there's limits to what the pigments can do as far as how chromatic they can get. So that just to, I just wanted to point out that, like, for instance, value 9 is just transparent red oxide and white. So I put it in this column, but it's not actually as chromatic as these here. Okay. So in this chart, for instance, I have moved those lighter mixtures. So the end mixtures are always just transparent red oxide and white, but I've swung them over to fit in the column of chroma where they belong. So, so that the lighter mixtures that are more desaturated are not in this higher chroma column over on the right. So it's a little bit different than the way I set it up here, where I left those lighter mixtures up in the same column, just to show that they're part of the same family of mixtures where it's just transparent red oxide plus white. And the same thing here. I left them here even though they're less chromatic.